All right, welcome to the program. Today's section 4.8 is about the quadratic equation. All right, this is in the Algebra II curriculum. This is when things start to really look like engineering. Okay, I went to engineering school, and a lot of times with the engineering problems, you need an equation, and you just need to know where stuff goes, and then you plug it in. So in engineering school, they say plug and chug, and that's what this section is. So before we actually use this equation, okay, let's go through a couple quadratics and identify in standard form. So for this first quadratic right here, what is the value of a? Raise your hand if you could tell me. The value of a for the first quadratic. Raise your hand if you could tell me. Done.
3.
3 is right. Matt Barbosa, what's the value of b?
2.
2? Good. And the value of c, let's hear from a lady. Let's hear from Angie.
5.
That's correct. Okay? So that's just the standard form, right? The standard form is ax squared plus bx plus c equals 0. Make sure that you set it equal to 0. So that's my second example here. All right? I'm going to try to trick you guys. Anthony Galvalanis, what is the value of a?
-4a squared.
Okay. Just the coefficient. What that means is you identify that it's this term that has the coefficient a, but you don't put the x squared, you just put the -4. So very good. Okay? Sam, how about b?
-1.
-1. Crystal.
0.
I'm going to give you the hard one. What is c in this one?
3.
Oh, man.
-3.
Why -3? -3 is correct.
Because you have to put it together.
You got to put it in this form, guys. So if you get a problem like this today in assessments, you're going to have to subtract 3 from both sides, all right, to set it equal to 0. All right? We have -4 x squared minus x minus 3. All right? So that's where the -3 comes from. You guys see that? Make sure it's in this form first. You going to sharpen now? Not yet. Not yet. Okay, here we go. So, how does this all work? There's 3 cases.
Well, yeah.
There's 3 cases.
Yeah, subtract 2 to
All right.
equal to 0. Right?
It all depends on, guys, this is called the discriminant, okay? It determines how many answers there are to the quadratic. We need this quadratic formula for when we can't factor it. When we can't get to something that looks like this, all right? This formula works for all quadratics, all second-order equations that can't be factored. So if this is not an option, which sometimes it's not, you can still find x, you can still find the solution by using this equation. So you guys have this written down, so I'm going to go to the next page, all right? And this is the case where we have 2 answers, and they're both real, all right? So you don't have to write this, just watch with me. Okay, is it in standard form?
No.
All right, so what do we have to do?
Equal to 0.
All right, by?
Subtracting 2.
Very good. X squared plus 3x minus 2 equals 0. All right? Now we need our equation. X equals, all right?
Yeah.
-b. What's b in this problem?
3.
-3 plus minus the square root of what, guys? What's the next thing in that equation?
B squared.
What is b in this problem?
-3.
Positive 3, right?
Whoa.
So 3 squared, it's okay.
Wait, why'd you put negative? Oh, never mind.
Because the equation has a negative beginning.
Yeah.
Plus or minus, I'm sorry,
No, it's
this
just
is plus. Minus? Minus plus, what is it?
minus 4.
B squared minus,
4.
it is minus. Everybody sees that it's minus? It's always going to be minus. 4, which is in the equation, times the a term. What's the a term here?
1.
Times
-2.
c term is -2. All over 2 times what?
1.
2 times a, which is 1 here. Okay?
Wait, what's
All right.
that represent?
We're getting x. If you notice now, there are no more variables here, so we're getting very close to getting our x value. These are all numbers. It becomes order of operations. And the trickiest part from last year, with all my Algebra II students last year, is in here with all the negatives. Confusing, leaving a negative off of here. There's a minus sign in the equation. You have to keep tabs on all this stuff because sometimes all three of these will be negative. Okay? Then you end up with a negative. So let's just look at underneath the radical for now. I'm going to leave the -3 here. Plus minus. And what do we have? 3 squared is?
9.
So we have 9 minus, what does all this become?
8.
Raise your hand if you can tell me what this becomes. Jeremy. -4 times +1 times -4.
8.
8. Very good. Downstairs we have what?
2.
2. Okay. Now, what are we left with? We have a -3
Doing that.
plus minus.
1. Square root. 1.
Well, what is the square root of 1?
1.
1.
1 all over 2. Okay? This is x, right?
Yeah.
So now we have a situation where we have negative, well, let's take the positive, positive first.
Negative
3 plus
2
1.
over 2.
Negative 2 over 2.
Negative 2 over 2,
So -1.
which is -1. That's the first one.
Yeah.
But there's another solution. What if we do the downstairs? 3
Negative.
minus 1,
Negative 4.
Negative
4. So -2.
-2. Now, if I did this correctly, when I go to graph it, what are our solutions?
-1, -2.
-1, -2. All right, so if I just a
second
crude
part?
graph. Does this open up or down, by the way?
Yeah.
Up.
There's
A determines if it opens up or down.
All divided.
All right. If this is a standard coordinate axis, and this is just a sketch, I would look for a parabola opening up with roots at -1 and -2. Let me see how close we got to that. All right.
Me.
All right. What was the equation? Anybody have it?
X squared
X squared
Plus.
plus 3x
Plus 3x.
minus 2.
Minus. No, equals 2.
No, minus 2
Equals 0.
Either way, it'll work. Watch, because it understands standard form. Equals 2? What was it before we put it in standard form? Equals 2?
Oh, man. You were wrong.
All right, let's try it the other way.
Yeah.
File, new,
What was it?
x
Squared
squared
plus 3x
plus 3x
minus 2 equals 0.
minus 2 equals 0. What do we have here?
I think someone.
Did we mess up?
No, I think Fiona was wrong.
Same thing.
-2, -1, right?
Yeah.
Wouldn't you have to add?
Does anybody see an error?
No, because like, go through 9 plus 4 times minus 4 times minus.
That's what it is. Jeremy found the error.
What?
What?
Beautiful. What is the error?
Good job, Jeremy.
4, -4 times 1 times -2.
It's positive 8.
All right?
Okay, that's what I said. I think you wrote it wrong.
I just wrote it wrong?
And we just
Okay.
solved it from there.
All right.
That's okay.
Okay. We can salvage
Erase
this.
everything else and
Exactly. All right? Hold on, guys. Let's finish this now. Thank you, Jeremy, for finding the area, the error with my problem. All right. So we
Good
have
job,
what, guys?
Jeremy.
What do we have?
Jeremy, good job.
X equals what, guys?
negative 3 plus
-3 plus minus root 17 over 2.
That doesn't make sense now.
Wait, it does. Watch. Okay. What's the square root of 17?
There is no.
No, there is. This is
There is.
decimal.
-3 plus minus, I'm going to approximate this 17, root 17.
I would say
That's why I pulled up this calculator, guys, so that we could do this. So we have 17, and we take the square root of that, and we get about 4.1. 4.1. 4.1 all over 2. So let's do the same thing we did before. All right, 4.1 minus 3, I'm sorry, negative 3 plus 4.1 is what?
7.1. No, wait.
Start with negative
1.1.
Wait, start with negative 3, add 4.1.
1.1.
1.1 over 2, all right? Which is approximately what? These are approximations now.
Around half.
1 over 2,
Half.
yeah, about, what, 0.55, something like that?
Yeah.
0.55, all right? And let's get our other root now. What's the other root?
Negative 7.1.
Negative 7.1 over 2, approximately what? Approximately
Negative 3.
negative 3.6?
Yeah.
Negative 3.6. So if we did this correctly, we have a root here and a root here. A root at negative 3 and some change, and a root at just in between 0 and 1. All right?
Then we did it correctly.
And what do we get? We did it twice. 3 and some change, and 0.5. Okay? So it worked. How long's the video right now?
11 minutes.
11 minutes. Thank you for watching. Hit stop.